Hello, my name is Tiffany Dennis. The Battery Building Challenge Unit was created by myself, Abigayl Buida, and Kristen Wilcox. This unit not only teaches essential STEM concepts, but also includes an exciting final assessment in which the students will present a battery grant proposal based on their research and experimentation in the classroom, as they work in groups to test different metals and electrolytes in an attempt to build the most efficient battery. Moving right into the engagement part. As a part of the engagement, we want to snatch their attention and draw them in with the unveiling of the mystery of the exploding cell phone batteries. It's known that previously with the Samsung Note 7, there were some debacles with the battery, big problems that caused them to explode. And for these problems, they were recalled, but it makes a great science lesson. Students will first be shown a very brief video by ABC News. In this video, it will depict footage from a Florida man whose phone exploded in his pocket as a result of these batteries. After the short video, students in their groups will think on the following question, discuss it, and be prepared to share out. The question being, what factors do you think might cause a cell phone battery to explode? We expect for answers to vary from anything such as overheating, short circuit, possibly the lithium ion chemistry, or simply just being a damaged or defective battery. Once students have shared out, in which they would do so either conventionally in a classroom on a whiteboard, or if you want to work digitally, on the Canva whiteboard. We will ask those groups to then come together and as a class discuss and come up with a concept map using many of the things that these groups shared out. In creating our concept map, we would do so either conventionally on a class whiteboard or digitally using the Canva concept mapping feature. Once we've developed the concept map, I would then kind of summarize what we've been talking about and the key points that were brought out in discussion. And we would watch a video as part of our reflection. So in the video, it will explain the Note 77's battery's flaws in a way that's simple and very intriguing for students. It will explain it like it was cake. After this brief video, we will leave the students with a question leading into their exploration piece. It kind of gets them ready to go into that exploration zone. The question being, why is it important for engineers and scientists to understand the causes of exploding batteries?
All right, so we are doing building batteries as our summer reset unit, and I've got the explore and explain sections. We're doing these in chunks, so we'll do a little bit of explore, followed by some explain, which is really just a lecture note format. This is what we decided to go with. Right at the beginning of this slide deck, we've got our NGSS standards for both high school and some middle school standards that also align with this curriculum. We'll start here with our first explore section. We're looking at click heat packs, reusable heat packs, and exploring this as a phenomenon for kids to talk about chemical and physical properties of elements and compounds, which goes along with our periodic table. There's also an optional MIDI lesson in here to talk about patterns. If this is something that you haven't done with students often, looking like very specifically at the cross-cutting concept of patterns, this is a great place for you to stop and do that. We'll skip through the videos just in the interest of time. I've also got a spot for your students to try it. So if you purchase these little reusable hot packs, you can activate them and have students make observations. We've got an observation table here. There's also an attached observation sheet for students to use. It's attached both in the slide notes as well as on our reset sheet that we made as a group. We've got a place for kids to ask questions, and then we're going to make a driving question board together as a class. We're going to bring it all together. And then once we've done that and let students have a chance to ask their questions and think through it a little bit together, we're going to explain what it is with this video that talks about how hot packs have a heat that they, or the compound within hot packs have a heat that a temperature that it freezes at, and that's actually what you're feeling, which is it's a high temperature, so it's hot for us. And then we've got the first explain section where we're talking about specific properties of elements and compounds. And then that brings us here to the periodic table where we are, we're looking at the periodic table and trends on the periodic table. As you can see from our slides here, we go through the history of the periodic table. We talk about metals and non-metals. We talk about the different classifications of those, halogens, transition metals, alkaline earth metals, all of those things. And then we get to the end of part one, right after going over all of those periodic trends. Our second explore section is a second phenomenon where we're looking at static electricity, and we've got floating rings here. Just like before, we have a spot to pause and talk about cause and effect. After
Hi, it's
that, kids will have a chance to do this themselves with a balloon and static electricity. There's a PhET simulation that helps explain it further, and then a video. And then our second part of our explain section where kids will learn about circuits and Ohm's law as well. So that's our explore and explain section. I hope you enjoy our unit. And now on to Kristen for our last portions.
We are excited to create a challenge that builds on the fundamental blocks of electronegativity and periodic trends that allow students to become the innovators of tomorrow by helping them understand the science behind one of today's most critical technologies, batteries. They start the challenge by diving into the world of electrochemistry by building their own batteries using various metals and electrolytes. They'll experiment with different combinations, including iron, zinc, copper, and aluminum, and different electrolytes, such as Powerade or Gatorade, lemons, apples, potatoes, yams, water, or salt water, to discover which materials would make the most efficient batteries. For this experiment, we do recommend students work in groups to minimize supply waste. The final assessment for this challenge will hopefully prepare students for future academic and career endeavors, as each team will present their data and findings and propose a grant for future battery research based on the information that they collected during the challenge. They will defend their choices of anode, cathode, and electrolyte materials, demonstrating their ability to apply the scientific method and think critically about real-world applications. If you have ever seen a lemon or potato battery, you'll be familiar with the concept behind the science of using citric acid or phosphoric acid as an electrolyte. We want to take this experiment one step further by also trying different types of metals as the electrodes of the battery. As students test each electrolyte, they will learn about which metals have an affinity for gaining electrons or losing electrons in order to determine which metals would be recommended for anode or cathode materials. As they try different combinations of electrodes and electrolytes, they will use a digital multimeter in combination with alligator clips to test and record the voltage for each specific combination. When testing liquid electrolytes, we find the easiest way to test the voltage is to set everything up beforehand and then place the electrodes directly into the liquid like you see in the video. Just make sure the positive and negative ends do not touch directly. Also, you can test using different temperatures of liquids, but the best results will be achieved when using warm water.